So given that here is a function x power of 4 minus 2x squared plus 1 is a polynomial function, degree of 4. Determine the interval of x where the function is increasing and decreasing. So to know the function increasing means we are referring to the gradient of the curve. Gradient of the curve indicate that it will be the first derivative of the function, or if you're using y, means it is the dy dx. So our function here, we need to differentiate it. Find the first derivative, power move to the front, power minus 1. So to get the function increasing, indicate that first derivative must be positive. So if gradient must be positive, means your f prime x need to be greater equals to 0. So not including 0. Including 0 means it will be your maximum minimum already. So it will be your critical point. Dy dx equals to 0. It will be like this, where the critical point or stationary point happen. If dy dx is positive, means gradient is increasing. If the dy dx is negative, means gradient is decreasing. So we want the function increasing means gradient increasing, so it's supposed to be more than 0. So which means that this is 4x cubed minus 4x need to be greater than 0. We can simplify by divide by 4. So to solve this polynomial inequalities, we can do factorize as I take out the x, and this quadratic can be factorized some more. So it will be like similar like quadratic inequalities. We solving it by using graphical method. So look at the x here. We have three roots where it is x0, x equals to 1, and x equals to negative 1. So you have three roots here. Arrange in order, negative 1 followed by 0 followed by 1. This is quadratic positive. So you will having a S shape increasing. Sorry, this is a cubic. So cubic is a S-shaped graph going up because this is cubic positive. And when you want to find out where is the positive region, we're going to shape above the x-axis. So this is the positive region. So when your gradient is positive, your x is fall within negative 1 and 0. Another one is this, x will be more than 1. So to find the function decreasing means our gradient is negative. When it comes to the gradient of negative means our f prime x is less than 0. So the procedure will be same until we get this factorized form. Alright, so the same graph here, the same point here, same factor, so same point here. And when we want to know where is the negative region, means it will be the region below the x-axis. So here we'll have and this. Therefore, your interval will be in the interval, your function will be in the interval x less than negative 1 and 0 in between 1. So this is the interval for the function increasing and interval for the function decreasing. So we do out some conclusion. Interval where the function increasing at negative 1 until x 0, x more than 1. So I can put in set notation also can. Meanwhile, this one interval for the function it is decreasing at x less than -1 and then 0 until 1. Alright, so for the question B, it is asking using the first derivative test to determine the local extremum. So we need to find out what is your stationary point first. Stationary point is dy dx equals to 0 or your f prime x equals to 0. So f prime x we already found, which is this. So we done factorize with our f prime x, which is x plus 1, x minus 1 equals to 0. We can know that we have 3 stationary points here. So after we get this x, we need to find our y coordinate, substitute this 0 into the function. So 0, 0 plus 1. Then substitute -1 into the function. This is +1 minus 2 plus 1. It is 0. Then for x equals to 1, substitute 1 into the function. Here we have 1 minus 2 plus 1, so it's 0. So we have 3 stationary points. So to identify whether it is maximum or minimum, we need to use first derivative test as the question request here. So to do the first derivative test, we need the table. Alright, so I will continue here to have more space here, as we know that our critical point fall at -1, 0, and 1. So our table here, our interval involved here will be arrange your x in order, so it will be less than -1, and then in between -1 until 0. So before this, after -1, and then before 0, after 0, and the x more than 1. Then we pick a test value here to substitute into our f prime x. So our f prime x just now is 4x cubed minus 4x. And lastly, we come out with the conclusion of the graph. So less than -1, we can pick -2. In between here, we pick -0.5. Here, 0.5. More than 1, we can pick 2. And when we substitute inside, we can get negative, positive, negative, positive, negative, positive, negative, positive. So conclusion, first derivative test is about tangent. Negative is decreasing, positive increasing, so decreasing, increasing. So you can notice here the point in the middle at -1, x0, x1. So from here we can identify that -1 is minimum point, 1 also minimum point. So -1, 0, and 1, 0, they are minimum point. And then we have 1, x equals to 0 point. So when x equals to 0, y coordinate is 1. So this is maximum point. Then after this, after we identify all these local extremum and minimum, maximum and minimum, based on the information above, we're going to sketch the graph. So when we come to sketching, we plot the important point first and label the axis, x-axis, y-axis. So you have two minimum points happen at -1 and 1. So here is the minimum point, 0, 1. So here 1, this is maximum point. And your graph, you can see your graph, -1 and your graph before -1, it is decreasing. So before your graph, it is decreasing and make it to be minimum. And this point, when you come to this point, you make it to be maximum. So a curve, maximum, and this is minimum going up again. Then you label your function. So this is polynomial power of 4. X power of 4 minus 2x squared plus 1. So you can compare here. -1 and then 0 until 1 decreasing. -1, 0 until 1 decreasing. Increasing, -1 until 0 and more than 1. -1 until 0, you can see graph is increasing. More than 1, the graph is increasing. So at last, don't forget to label. X-axis label, y-axis label, maximum, minimum point also label. So here we have -1, 0. This is 1, 0. This is 0, 1. And label your graph function, fx. What is your function? Okay, so that's all.